Hello, this video hi rotational motion chapter adinga masapen hain system of particles khona system of particles NCERT apen hu center of mass part to rotational part here chum hi standard books of velocity ki hom khending hindin na but in NCERT you have these two combined in a single chapter. Okay, to hi chahi in hop khendiu za center of mass part si chu khavia video ma sa chuna e bol chai wetain to hi moment of inertia part to rotational part I focus do na. So chi video ho hi JEE to NEET focus ana completely JEE and NEET focus I bolo hi tin jeja chu lecture chi dan jong hi ma sa pen class lecture om na concept ho ka hil deu concept zo phala chun question het khalani cho concept het chim ni question khalani bol na previous question ho jong bol deu so chikal wala chu. So once you're comfortable with the core concepts na ne thim phala chun you have to practice. Okay, lekha khat book ki koi velang na example so need preparing ni wala so need book ni ki koi dio chi need book ko na so practice na bol na chita bang so je ya jong chu for example fingertips on na wala chun fingertips question ki practice dio na medical exam ari nga chu. So like that. Okay, aji chu chi lecture bo si a hi question tampena chu ni thumbo se concept khana ki solve thai na chi chu, so that is not enough. Okay, so you have to practice more questions. Okay, so let's see masapena chu moment of inertia. Moment of inertia i bol masang chat wa hena rigid body ki ti he thim ngai chu he chi standard books okhon velo chun chapter pa hi rigid body dynamics ta jong ke sei chu chi rigid bodies ki ti chu pitena ha. So tang song he na song khu velo chun, so try to compress a stone. Okay, song khu son le chun, so apply force apply le chun ni pitire. So if I apply force on a stone here, okay, so what will happen? A kielo ngal la chun ki son zo lo pi chuna song ho, it is incompressible. Okay, simple ta asini nga chuna. So if I take any 2 points on the stone, so the distance between these two points, even if I apply external forces, it will not change. Okay, ki hello this point ten ki ka chuna ai wanga chu sponge ne na chuna sponge chu bi ha for example kung sop na ha ki bang khol na sponge he chi sponge hu point ni la le chuna la hi point la le chun point ni chu tu hin force applied bol le chun na ki compress thai chuna, it is compressible. Okay, sponge is compressible chi ja chu chin force applied bol le chun he chala atila x1 pa he bel chun chala x2 pa he da. So now x2 is smaller na aji chu ki compress thai chuna compress wala chun a shape chu ki hial da sponge pa shape chuna chala hi, so you'll find that x2 is less than x1. Okay, aji chu sponge is compressible. Okay, so here stone to hin sponge pa he na which pen hi rigid body he za which pen chu rigid body he lo ha. So the distance between A and B, okay, will not change if external force is applied. In case of stone, okay, in case of a sponge, so it is compressible, na. So here the distance between A and B gets smaller. So here the stone is a rigid body, whereas the sponge is not a rigid body. Rigid body, so definition, so the distance between any 2 points on the body does not change. Okay, so if I put A and B here, even after applying external forces, so the distance A and B keeps so that is a definition of a rigid bodies. Okay, example 2 stone na non-rigid body to example 2 sponge. Okay, abana so rigid body khat hong ma la chun na si rigid body pa chu, so how many types of motion can that rigid body performs? Rigid body yung kiti pala chuna. So normally it performs 3 types of motion. Okay, masa pa so purely translational kitiya, ani na pa so purely rotational kitin din. Abale the case of translational plus rotational. Okay, ani niya perform home na. Examples of itang block khat so block khat hi son le chun a motion cho piha a motion cho translational chuna. So there is displacement. Okay, displacement if I push this one, it will cover some distance here. Okay, so some displacement covered here, so that is translational. Abana so rotational so piha hita displacement umlaw ai wanga so kipay na rotation din cho he chi pa hi ki fixed dan cho chala. So now this is fixed and it is rotated. Examples of fan na fan kipay ho chu rotation din cho chi ho. abana chu wheel of a car lai phal khum keng khoveleu chun so rotation zong abana chu at the same time translational zong na displacement zong chukil le rotation zong tin combined translational plus rotational. Okay, right, three types of motion: purely translational, purely rotational to combined translational and rotational. Okay, masapenin aban ban ne vetena cho masapena cho purely translational cho piha. See, suppose I have a block na block khat cho heji block pa hi suppose center of mass chila hi chola na ji, so this is the center of mass. Okay, if the block is moving with speed v, center of mass pa na speed v a chia la chun, so I'm going to take some other points. Okay, suppose point A, point B, random points. Okay, point C, and then point D. To block pa hi v a chia la chun, so point A, B, C, D ho zong hi speed pi hi them. So what will be the speed of A, B, C, and D? So it will block to rigid body chula na. Rigid body heja chu distance between any two point is fixed. Okay, a point ho zong chang lau de. So that means if the center of mass is going with V, heji D zong hi v a chi ding, A zong hi v a chi ding, B zong hi v a chi ding, chukil C zong hi v a chi de. Na point zong si chun same velocity ni anai de tin cho. Aji chu block pa chu rigid body chula na da he. Okay, so if a body undergoes purely translational motion, so every point on the body, okay, heji body sunga point zo si chuna, so every point on the body will have the same velocity. Okay, so that is the case of purely translational motion. Heji point pa chu mial si ta. Okay, so here if a rigid body undergoes purely translational motion, every point on the body will have the same velocity. Okay, so remember, and equals to the velocity of the center of mass. Center of mass pa chuna via chilchun point dang zau si zong a body a point dang zau si on cho via chi ting na cho if they perform purely translational motion. Okay, abana chu purely rotational motion heji he pikes ta. Suppose hita ki chalai ki fix so lai he, so here it is fixed in the middle. Azo a fan is a pau chala na chalai he fan tabanga chu now it is rotating, okay, with omega cho biham angular velocity. Alahin azo atabanga cho point chila hin na point say point A, point B, point ni ga lang point ni ga la chun chila ya hi A pa hi, let's say it is a distance of x1 to then B pa hi at distance of x2 na atila A hi point A hi velocity p them. So here this is the velocity to rotational velocity along the tangent chula na chi. So here what is VA chu piha omega into r, circular motion imbolai wa chu V chu piha omega into r it is chula na jala here ale point A pa hi value chun A pa hi ta hi circular motion perform cha. Okay, ale a radius chu piha radius chu x1 na atila VA chu so omega into x1. Okay, right, velocity at A is omega into x1. Similarly velocity at B chu that VB chu omega into x2. Okay, hey vanga point he diu chuna rotational ke perform ala chun, so every point, whatever point you take, so this will rotate around the fixed point. Okay, point B zong ki rotate ding a hi vanga chu about the fixed point. Okay, about the fixed point they will rotate it. So rotational, purely rotational motion I think properties they had dikhat cho. So here if a rigid body undergoes a purely rotational, then every point on the body will rotate about the fixed point. Ake fix na lai chola na ake paina axis pa cho chalai about that axis also tai every point will rotate. Okay, velocity holan so v equals to omega r so here sao na la. So point A distance of xa, so the velocity will be so omega into xa na omega into r. So lahi xb to radius is so omega into xb. Same thing for c also, omega into xc. Okay, chukile na chila hi to he ki fix cho la hi ale ki fix lawin na, so ki fix lawin hechi purely rotational motion hi perform tale. Suppose road so na si road ne aning aman vilanga ali to lechun, so it will go and rotate it. Okay, ke pai di na thing chu. So in that type of motion, okay, fixed point om lawa la chun. So if a rigid body undergoes purely rotational, so freely, okay, fixed point lawa, okay, fixed lawa freely purely rotational perform la chun, every point will rotate about the center of mass. Okay, so just remember that point there. Ale athumna pen chu piha combined translational plus rotational diu chuna je. So here example again a wheel, okay, to a wheel pa ke fix lo ta chu. A hi wanga chu ke fix lo wanga chu chala hi tool chunga hi gari keng ba khona na che. So now it is moving, okay. So it is moving with speed v, at the same time it is also rotating with omega. Okay, speed v azong si omega azong ki rotate na, combined translational plus rotational. Chala hi point ga la leo chun na. Example, so let's take a point A hila hi. So point B, bottommost to point C, abana chu chilang hi point D, point li lao to chala hi. Ale point A hu net velocity chu pi hidam. Batang combined translational to rotational ke tiel chun, translational zong perform ding, rotational zong perform di chala na. So first let's see if it performs translational, aso property say pita every point will move with the same velocity ti chala na. So here here you'll have V, center of mass of V achi chala na. That means every point will go with V. B zong hi V achi ding, C zong hi V achi ding, abana D zong hi V achi di cho. Okay, first thing. As you translational as out chu point zo si jong chu center of mass velocity achu chi di cho. Okay. Ale ani na pen chu pita rotational hi la chun. So every point will rotate about the center. Okay. Chila hi point ya hi rotation hi la chun chi radius cho chi pen hi. Radius hi r ti lew hen na. Ale velocity chu omega into r along the tangent. Chila na zo pen chu. Ale point b ya hi omega r hoilang dia. So omega r chu along the tangent. So this is omega into r. Okay. Chita banga cha point C hi omega r hoilang dia. Ake paidan hi velocity clockwise ake pai cho. Clockwise ake pai lesion velocity at C chu along this side omega into r. Omega into r pa hi rotation ji a chu chipen hi. Okay. Similarly at D, where is omega into r? Upwards. Okay, omega into r. Alechun to hi translational to rotational combine hi chu velocity ni ne na omega to omega into r to v ne chu. To hi resultant hi hold dio ji. So here if I want to find out resultant at A, so VA, okay, I'll use black. VA equals to what? V plus omega into R. As you direction ki bang chula na ni ni hona ko velachun V to omega R ko point A ko na. Omega V plus omega R heading habana so point B na ko velachun V chu chilanga ma omega R chu chilanga na ani ni hona vector so. So therefore the resultant will be somewhere here. Okay, angle between them is 90. Vector addition manglason V square plus omega R square plus 2 into AB cos theta cos 90 to 0 na. So here here the resultant will be somewhere like this. Okay. See V net to be VB to so V square plus omega R the whole square under root. Okay. Just net velocity at B. Abana hi C hi la C hi V pa hi plus lang ako omega R pa hi minus lang ako na. So the net will be V minus omega into R. Okay. Ale D na pa hila. D na hi piham. So D na chu net chilang hi na. Okay, net chilang hi ma. So V D zong chu VB to kibang da chu. So V square plus omega into R the whole square under root. Okay. Aji chu V chu chilanga ma omega R chu chilanga hi ma resultant chu chilanga hi achi ngai na. Aji chu vector addition ni man diu chu chilai. Okay. So here in general, okay, velocity is like this. Rolling ahe na. So we call this rolling, okay. The combined translational to rotational pa hi rolling zong kiti chu. So in case of pure rolling, okay, pure rolling ke ti condition ngum phala chun he chi hi in detail la all lai se dio video da nga na. Pure rolling condition ho bhiam tele V is equals to omega into R. V to hin omega R ke bangji ta chu pure rolling ako. Ale he chi condition hi apply leo chun. So here I will have V plus V is 2V. Okay. So VA is 2V, VB ako piha. So V square plus V square under root. So this is root 2 into V. Okay, B acha na. Let's see ahi V minus V, so this is 0. Okay, bottommost point acha velocity 0 ong hipala chun jo pure rolling kiti cho. And then D ahi, so same thing. V square plus V square under root na chahi root 2 into V. Okay, right. So let's move on. Chahi rolling case. Okay, purely combined translational to rotational motion. Okay, the third type of motion. So 3 types of motion: purely translational, purely rotational to combined translational plus rotational. Okay. So here you see to is ho chang chang na. So point ia chu velocity v to omega r ma net chu v plus omega r na. Chita banga chu chela he v ma omega r ma net chu v square plus omega r square. Okay, so similarly v minus omega r. Okay, whatever we have said na. To chu in case of pure rolling, okay, pure rolling chu piam v equals to omega r apply le chun chela he 2v hum ding, chela he root 2v hum ding, chela he 0, chela he root 2v. Okay. Tile question got solved for that na chela he chu case ahi motion of rigid body ahi. So first question chu consider the wheel of bicycle on a level road, linear speed to v naught. Okay, His linear speed v naught kati center of mass speed ke sine chochi. So point O pa hai na. So point O pa hai. So point O is going with v naught. Option mas apeng hopiam the speed of the particle A. A chu hoilai ham bottommost point. Okay. Bottommost point chu silanga hai v ma back side hai omega into r na chi. So here matang he pure rolling is consider wala chuna. So here if this is pure rolling. Okay. So if I consider this pure rolling, bottommost point as a velocity to pita. So VA is 0, right? So so VA is 0. The speed of the particle at A is 0. Okay, so that means option A is correct. Okay. Abana so option B khola. The speed of at B to hela chalai na. So I bolva so V naught is a hilanga hi omega r square hong lesson net to pita. Net to root 2 into V. Okay. V naught na center of mass V naught. So the speed of particle at B, C, D are all equal. Kibang lopi chola na C chu piha C a chu 2 V naught mo wa chu. So D a jong value chun omega r chu rangam ding. Okay. So speed V chu rangam ding na. So the resultant will be somewhere along this side. Okay. It will not be V. Option B na chu incorrect. The speed at C is 2V. C chu hilai ha topmost point C chu na chalai 2V chu na. So now this is correct. Okay. So C is correct. The speed of B is greater than that of O. O chu piha center like ho. So O speed ho V naught is a B speed chu piha root 2 times V naught chula na. So here it is correct. Okay. B is greater than D or O. Okay. So root 2 into V naught is greater than V naught. Okay. So answer is A, C, and D. Banachu a wheel of bullock chipen hi medical exam question na 2024 question. A wheel of bullock cart is rolling on a level road as shown in the figure. Its linear speed is v. Tichu center of mass speed chu na v ti ne chachi. In which of the following correct option is correct? Masapena so P moves slower than Q. Masapena so P ahi velocity chu piham so 2 into v. Okay. Q ahi velocity piham so 0. VQ is 0. VP is 2 times of V naught. Okay. Ale P moves slower to DM. V is 0 zachi 2V chala. P moves faster. So chala P moves slower is wrong. Okay. Option 1 is wrong. Point P moves faster than Q. Okay. This one is correct. Yeah. So point P and Q move with equal speed. So that is wrong. Okay. They have different speed. P to 2V achia, Q to 0. Na. Point P has 0 speed. That is wrong. Point Q has 0 speed. Okay. Right. So this is a neat question. Abana hi. So up to that much. Okay. Azo wheel pai bolo. So na hi sepen het him valachun. So this much is enough. Okay. To chu moment of inertia abana next topic chu rigid body ke che moment of inertia na. Mitang moment of inertia ke ti hi pitena ha. Suppose I have a rigid body. Okay. So this rigid body is, let's say, fixed here. Okay. Fixed here, and now it is rotating about this point with omega. chi rigid body pa hi ki paiti na cho but hi chapter hi rotational motion cho chi ja so thil zo si na so whatever you are going to learn so always there will be rotation ki pai jing ni cho rotation jing na chala hi atile hin chala hi na object rigid body pa hi so this is a rigid body okay rigid body pa hi fixed point hi omega ki rotate cho that means here if I take a mass m1 on the body so mass m2 on the body mass m3 ta hi mass tam da kra chuna body chunga hi new mass new la lechun suppose I take mass m1 at a distance of r1 so I take mass m2 at distance of r2 and mass m3 at distance r3 tiute okay hita zo tam na m4 m5 m6 ta hi cho ale hin hi chi mass ho he na a speed hi hi langam de ha so here aki rotate along the tangent hi ngai chuna velocity cho so velocity is what omega into r1 here okay m2 a pm omega into r2 okay m3 azong hi omega into r3 chita bang so omega into r4 m4 azona m5 m6 ta cho okay so there are many particles here na alahin amo si hina if I want to find the total kinetic energy of this rigid body okay rigid body total kinetic energy ko holding ala chun biha so what is the total kinetic energy half into m1 into v1 squared plus half into m2 into v2 squared plus half into m3 into v3 squared plus and so on okay rigid body chu ai mass new tam jala na jem bon jang ke chu individual kinetic energy si na samala chun na so you'll get the total kinetic energy okay jela hi v hi biha v hi so half m1 into so v is equals to omega into r na jela hi tang chi v1 pa hi biham omega into r1 v2 pa chu omega into r2 like that okay ama hosi si hi fixed point hi same omega ki rotate hu cha bon wa hi okay hutile v hela hi omega into r1 ka zi theina square plus half into m2 into omega into r2 squared plus and so on okay so here what can I do so half into m1 into omega times of hi velocity omega chuna common so I can take that outside okay abala chun half jong common na bona ko so here I'll take half common so remaining to piha m1 into r1 square plus m2 into r2 square plus m3 into r3 square plus and so on into omega square okay omega pa chulo do lang na half pa chulo do lechun remaining to piha m1 r1 square plus m2 r2 square and so on like that okay so what is this quantity this quantity is what I is equals to m1 r1 square plus m2 r2 square plus and so on. So in general, you can write as summation of m into I, mi, ri, the whole square. Okay, I is from 1 to whatever number you have. Okay, so this quantity is what we call moment of inertia. Okay, moment of inertia. Capital I ki represents. Okay, so therefore, what is the kinetic energy? Kinetic energy is equals to half into I into omega square. Kinetic energy formula is na rigid body ho. So here, kinetic energy of a rigid body is half I omega square. I to pm I to moment of inertia. Okay. So in general, moment of inertia formula is pm m1 r1 square, m2 r2 square, and so on. Okay, like that. So this is the moment of inertia. Atile hi formula pa hina moment of inertia hi system of particles sa chu iti ki apply ham ga ta question khale ni ga solve te. So first is I have a system mass thumom na 1 kg 2 kg to 3 kg ma coordinate jong ki pi jela hi. So in the given system of particles shown in the figure, calculate the motion of moment of inertia of the system about the origin. So moment of inertia question ongi do phale hina. So one thing you can see is, so they will always ask you about something. It's about the origin. So that means the whole thing is rotating about this origin. Okay. So particle they are all rotating about the origin. Okay. find the moment of inertia about the origin about so that is the fixed point. Okay, that is the point where the whole system is rotating na alehin chila hi I whole loading wala chun to hi mass thom om banga hi na so mass thom om jachun moment of inertia japiham m1r1 square plus m2r2 square plus m3r3 square. Okay, m1 to 1 kg pa m1 tiuten 2 kg pa 2 tiuten 3 kg pa 3 tiuten na ale chila hi beta azo ai se chu he chi r1 r2 r3 hi ha r1 chu biham r1 is the distance of this mass from the axis of rotation. Okay, similarly r2 chu biham so distance of the mass m2 from the axis of rotation. Okay, atile chila m1 pa 1 kg pa axis of rotation apara chu ichana gamla am. So how much is this? So this is 5. Okay, abana m2 pa ichana gamla am. So this is 4. Okay, ale m3 pa ichana gamla am. M3 pa na right side haokipiit na. So therefore, so m3 r3 is 0. Okay, axis also mass hongumala na moment of inertia due to that mass is 0. Okay, as you r telo pichula. So here you apply the value 1 into so 5 square plus 2 into 4 square plus 3 into 0 square. Okay, is that they have 5 5 25 plus 4 4 16 16 to 32. Okay, plus 0 sum down 57 unit happy ha. So mass to kg na r jo pe ha meter chula r square to meter square kg meter square. Okay, kg meter square to moment of inertia. Right, next problem. 3 particles each of mass m are situated at the vertices of equilateral triangles side L. Find the moment of inertia of the system about ax. Sila axis kipi pa heveda ax ha. So this is ax. Okay, atile chun hi chila axis apara hi mass hoi ichanchana gamla hami holongai cho aji chu hi choi r hong idi chula na m1 r1 r square r pa ho. So here you have how many masses? So 1 2 3 masses. Okay, mass m1 pa hi axis apara ichana gamla am 0 na aji chu it lies on the axis. Okay, abana mass m2 pa hi ichana gamla am l la gamla na mass m3 pa ho ichana gamla am. So here you see this is equilateral triangle. Okay, atila chun hi chi hi l a hi ala chun. Okay, that means so this will be half of l by 2. Okay, that means m3 pa ho l by 2 gamla na chila hi. So apply the formula. So I to biham m1 r1 square plus m2 r2 square plus m3 r3 square. Hitia hai na. So mass thum om ja. So center of mass formula in apply jita bang wa so chila hi. Moment of inertia hai na. He formula ki bang jing so. So m1 hu m na bona mass ki bang za m into 0 squared. Okay, it lies on the axis plus m2 hu biham m into m2 just na gamla am l la gamla na m square plus m3 into 3 pa hu l by 2 gamla so l by 2 whole square. Solve leuchun 0 plus ml square plus ml square divided by 4. Okay, so here you'll have 5 ml square divided by 4. So this is the moment of inertia. Okay, Banatsu. 4 particles each of mass m are kept at the corners of a square. Square ni na so square tayo ma 4 particles mass m to mass m. Tayo mo sa side to piham a kipina edge of a square side a. Find the moment of inertia of the system about the line along one of the edges. A part so A part. So here along a line, one of the edges chilahi. So this is the axis. Okay. Bedang chilahi about a line along one of the edges. Hichi line hi ki rotated in so bon na. So here the whole thing will rotate about this axis. Okay. Is that the moment of inertia? So let's say this one I here is equals to m into a square na distance to a hisa m into a square hichito hi hichipa hi chiten hi line they lie on the line na, so therefore moment of inertia due to them is 0. Okay, r0 na. So I'm going to skip this one. I will write here due to this. Okay, 1 2 3 ga ko ito so here 1 2 3 4 the formula jo piham so m1 into r1 square plus m2 into r2 square plus m3 into r3 squared plus m4 into r4 squared. Okay, value to ppd ham so m1 ko 0 na, so here they lie on the axis. Okay, m1 to m4 to they lie on the axis, therefore moment of inertia is 0. Okay, so this is 0 and 4 is also 0. Remaining to piham so 2 na, 2 who m into a squared. Okay, 2 is at the distance of a from the axis of rotation. It's a na abana 3 pasong hivilachun, it is at the distance of a. Until m a squared plus m into a square, so total is 2ma squared. Okay, a part na. Next you have what b part. B part here a line passing through the center and perpendicular to the plane. To hi line khat hi ball jing to na next badang chila hi psm line passing through the center pass through ding a hi wanga chu a plane to hin perpendicular ati chu. Okay, so that means the axis is like this. It is coming out of the plane na, the plane here. Mita hi bada X here, Y here. So now the axis is along the Z axis. Okay, it is into the plane and coming out of the plane, right? So now it is going to rotate about this. Until mass to center up half of diagonal side to A chulana diagonal to root 2 into A is a half to A by root 2. Okay, so all of them are at distance of A by root 2. Okay, a bond na A by root 2 almost okay from the axis of rotation na. So therefore what is the moment of inertia? I will be equals to m into A by 2 root 2 whole square to he plus m into A by root 2 whole square. Okay, plus m into A by root 2 whole squared plus m into A by root 2 whole squared. Lita chula solve lesson sa podham matang m a squared by 2. Okay, into 4 times so 2ma squared. Okay, so this is your answer. Tumna penso piham a line along any one of the diagonals along the diagonal like this. Okay, so it is rotating like this. Along the diagonal here chilaya mass pa to hin chilaya mass pa hi ani new line hi exist they exist on along the axis of rotation na. Axis of rotation allies achu amani chunga hi, so moment of inertia due to these two mass is 0. Okay, r is 0, so directly you can write here. So what is I? So what is this? How much is this? Half of diagonal A by root 2. Okay, kharpa jong hi A by root 2, half of diagonals. Okay, A by root 2 na. So here what is the moment of inertia? M into A by root 2 whole squared plus m into A by root 2 whole squared. So A by root 2 whole squared to A squared by 2. Now A squared by 2 plus A squared by 2, you have ma squared. Okay, that is your moment of inertia. Okay, chisan system of particles moment of inertia ki hold on na. Abana pala hi rigid body kharong ki pial chun ama moment of inertia cho piham si value cha. Ale system of particles moment of inertia ki hold on na. To hi rigid body song ki pial chun rigid body pa na moment of inertia cho iti ki holam dit pa chen bolyo cha. See, first thing abana ichi masangwa na. Moment of inertia ki hold on hi theorem nium cho chila hi theorem tani video hi theorem event masangwa cho ne he ding cho. So about the center of mass, okay, moment of inertia pa hai na. Hi derivation hi integration mangcha ki bola hin de na ai wanga cho chila kan bolo de cho. So I will not do any integration, but you have to remember this. Chilai value kan pi ho na heji at least is that haji sagi na heji ho sagi hin na bai ha te de moment of inertia about the center of mass na bai ha te de mas apan chu rod cho chilai so I have a rod here heji rod here mass m length l na so about an axis passing through the center of mass rod to center of mass hoilai ma alai ta am na chilai so this is the center of mass. Okay, center of mass about a hi axis khat au ma chi axis a hi ta ke pa ya la chun moment of inertia to pm ml square by 12. Okay, remember. Chita bang so ring ahung mala chun na ring radius r mass m radius r about the center of mass of a ring to exactly at the center alai ta am chuna chila hi atila chun ring adinga moment of inertia about the center of mass of pm mr squared. Okay, abana so disk ring tabang ahi banga jo solid. Okay, solid disk mass m radius r au mala chun moment of inertia to mr squared by 2. Okay, right, abana chu hollow sphere hechi example bubble kan la aizana hollow sphere khana hung mala chun moment of inertia about the center of mass axis passing through the center of mass of pm 2 mr squared by 3. Okay, solid sphere to pm 2 mr squared by 5. Okay, abana chu chi bia chi hollow cylinder cho chi hollow cylinder to hin ring hi ki bang cho chi ibija ki bang ham tele hi chi ring hi na tu hin chi ta bang ring khani chunga thup min lang na achunga itin thup to le chun so finally you'll get a hollow cylinder. Okay, chi ja chu ki bang cho hollow cylinder to mr square abana solid cylinder jong hi na to hi chilai disk pa hi na chi ta bang hi nga vel thup le chun solid cylinder ang po do de cho. Okay, so here moment of inertia of a disk and solid cylinders are the same thing. Okay, mr square by 2 mr square so hollow cylinder to ring chu mr square na hollow sphere chu 2 by 3 mr square heza bana chu solid sphere chu 2 by 5 mr square. Okay, it's about the moment of inertia pa na it's been hit it. Oh, you have to remember this one. Okay, let's solve one or two questions. First question jo piha hechi medical exam question na direct question cho hechi beta. So the moment of inertia of a thin rod ki pi na about an axis passing through its midpoint. So midpoint cho pi na midpoint to center of mass ti ne cho. Okay, so I have a rod hita hi rod na chi midpoint chu chila hi. So here midpoint is the center of mass. Okay, about the center of mass ml squared divided by 12 azo pen na alechela hi pm perpendicular to the rod. So here this axis is perpendicular to the rod. Became moment of inertia kipina chi. So here I is given. So they ask you to find the length. Okay, mass on kipina chi mass on kipia. So you have to find L. So I is equals to ml squared by 12. I chu pm I value kipi chu 2400 gram per centimeter. Mass on gram ma options of centimeter am khud le conversion ma bangalai oh tahim. You don't have to do any conversion here. I equals to mass to 400 gram into L squared divided by 12. So you transfer everything. So 2400 into 12. So divided by 400. So this is equals to L squared. 0 gets cancelled out. 4 6 are 24. Is that the hachi? So 6 2 are 12. 6 1 is 6 7. Okay, so this is L squared. Atile L to be root over 72. Approximately is that item root over 72. So here I have 88 or 64. Okay, values are holding. So see if hechi masanga 72 masanga perfect score to be 64 na 88 or 64 99 or 81 atile chun. So who is closer? Hechi 72 hi value 72 hi 64 to 81 ki ka ala am na. So here it will be approximately, here at the option you have 8.5. Okay, 8.5 square. Chichu badang adang hoy option available 17.5, 20.7, 72 hi so they are very very large na chi. Chila ni hedi khot ml square jo chila hi root ong kila chon root 72 chu 8 square 64 to 981 ki ka am na 72 chu. So therefore the correct answer is approximately 8.5. Okay, like that. Problem 7. Moment of inertia of a rod of mass m, length L. So about axis passing through the center and normal to the length is alpha. hitia hi rod khatom na chi hi rod pa hi mass m length l cho chi ale axis to passing through the center and normal okay chu pi ha I com ke seina chu lai na chu ml square divided by 12 okay chi value hi pi ke pm chi alpha ke pi cho chalai ale abana hi pm so the rod is cut into two equal parts okay two hin rod hi bong ni su leng na so first part chi pa hi bong khat za chi hi mass chu pi ha m by 2 ke su da chu chalai total mass m chu half an cut value chu m by 2 to m by 2 din na mass ten chu bana length zong chu l by 2 hung da cho chalai similarly khat half khat pa zong chu m by 2 comma l by 2 to chu pi ke se question ahi so they are joined symmetrically to form a cross shape cross ne he na ta hi rod khat pa ta ma khat pa chu ta okay so the other rod is like this ne cross ki form ha bana chu moment of inertia of the cross about an axis passing through its center and normal to the plane chu helai ha so here the plane is xy plane okay rod ten hi xy plane a ma khotele perpendicular to the plane hin z axis ten chu chalai okay axis is along the z okay that means into the page or out of the page na chi hi axis is a tila chun tang rod khatoma okay alai ta hi axis hong ma perpendicular to the rod hil chun ml square by 12 chuna formula chu a hi wa chu chala hi pi ha m zong m by 2 is a l zong l by 2 chula na chala hi so therefore what is the total moment of inertia will be the sum of those two okay I1 plus I2 diute khat pa hi 1 khat pa hi chu 2 na so formula is ml square by 2 so 12 cho chala hi so m to m by 2 ta na to hi so m by 2 into l zong to l by 2 okay square divided by 12 plus again m by 2 into l by 2 whole squared divided by 12 so you solve this one zarang pod di ham so m l square divided by a2 or 16 a1 is 9 plus ml square divided by 96 rating pot ha so chalai 2 khalom na 2 2 are 4 4 2 are 8 8 into 12 to 96 okay so jiteni goble chun ml square divided by 96 by 2 to 48 okay cross pa moment of inertia to 4 ml square by 48 na question chun pi do alpha do in terms of alpha so alpha to become ml square by 12 chala hi so therefore I can write here ml square by so 12 into is ha 4 na 48 so ml square by 12 pa hi become chipeni alpha okay so therefore this is alpha divided by 4 okay answer to alpha by 4 okay so tu hi moment of inertia ki Holdan theorem ni na so two theorems, two very important theorems. Masapa so pikitiam theorem of parallel axis. Okay, parallel axis. Axis ni parallel achi ta hai. Okay, that is parallel axis theorem. Chira hin he du formula pa hai na, je formula pa hai na ba dio. So I is equals to moment of inertia about the center of mass. Chipen cho jawa ba hai ringati pa na je you have to remember. Okay, plus md square. Okay. M hi piham mass of the rigid body d chu piham separation between the two axes okay so this is d right moment of inertia about the given axis to I is a whole body paso na I com chu piham moment of inertia about the center of mass chipa hina by hadio you have to remember but d chu piham separation between the two axes so that means this is d okay formula so ICOM plus MD square. Formula apply dani bawa sim deo. Derivation masaka bolo chislahi. So let's see first problem. Find the moment of inertia of a rod of mass m, length L, about an axis at a distance of L by 3 from one of the end. Nati chislahi. Rod khanoma from one of the end at a length L by 3. Okay, chislahi axis khanomna tahi. Okay. Axis khat maintain so now the whole thing is rotating about this axis okay question ake do pa na question pi pa chu he chi about the axis a hi moment of inertia whole ventil chun chila axis a chu ki rotate ne chu. Okay, so this is the question AB. Alehin batang question na p pa axis pa chu ji da chu na to chu parallel axis theorem man na chu axis dang kha zongai ki chala. Okay, he chi axis pa hi hoilanga is it ha, so it should be about the center of mass. Center of mass omnalai ta chu na COM omnalai ta chu axis khana drawing within he chi axis pa chu given axis pa chu parallel hi ngai chu. Okay, that is the condition. So above the center of mass you draw one axis, so which is parallel to the given axis. Okay, right? Center of mass so now I'm going to draw one axis about the center of mass which is parallel to the given axis. Okay, D is separation between the two axes. So this is D. D is so half to center of mass so that means this side is L by 2. Okay, half of total length na. Atila chito hin china go vala chun L by 2 so ding a hilole. So how do you find D? So this D will be given by so L by 2 you subtract L by 3. Okay, L by 2 la kona L by 3 la role chun, so remaining to D chula na chi. So how much is this? So here you'll have L by 6. Okay, now I have D. D ta mass zong ta ICOM chu pita. ICOM chu ML square divided by 12. Na ro da chu. So apply the formula. Formula chu piham ICOM plus MD square. Okay. ICOM chu ML square divided by 12 plus M into D chu piham L by 6 the whole square. Okay. Chu piha ML square divided by 12 plus ML square divided by 36. Okay, so 12 into 3 to 36 na. So 3. Okay. Gom na chun piam 3 plus 1 to 4 ML square divided by 36. 4 1 is 4. 4 9 are 36. So therefore this is ML square divided by 9. Okay. So chipahi. So this is the required moment of inertia about the axis which is L by 3 from the end. Okay. Parallel axis theorem na kimandan ba chu chala example kan so chala hai. Question khali ni bolbe to chala hai. So here see, find the moment of inertia of a ring ki pina chala hai. Mass M, radius R about an axis R by 2 from the center and perpendicular to the plane of the ring. Betang ring chu hita hang malachun okay, toch question jan pido ham R by 2 from the center. So at a distance of R by 2 I have one axis. Let's say AB. Okay, the whole thing is rotating about this axis. Now about an axis R by 2 from the center and perpendicular to the plane. A plane pa chu plane pa chu na perpendicular to, so like this. Okay. Question so here we have to draw another axis. Okay, passing through the center of mass and parallel to the given axis. So that is this one. Okay, so now this is the ICOM. Is that ring also MR squared? Okay, remember. Abana D chu piham. So this R by 2 is D na. D is a D chu piham R by 2. Question akipita chu. Atile formula chupitam. So I equals to ICOM plus MD square. ICOM to MR square plus M into D chu piham R by 2 the whole square. So this is MR square plus MR square divided by 4. Okay, so how much will you have? 5 MR square divided by 4. Okay, so this is I. So moment of inertia about this axis for a ring is 5 MR square divided by 4. Okay. Next question. Find the moment of inertia of a solid sphere. Okay. Having mass M radius R about axis passing along the tangent. Sphere chu ito bang ha. I'll try to draw a sphere here. Okay, so this is a sphere. To achu axis chu betang along the tangent ati chola tangent chu piha. So here this is the axis along the tangent. Okay, let's say AB. So the whole thing is rotating about AB. Na chila hi. Given axis chu chi hi za e honi people be diu ha. So axis kha draw diu na. So that axis has to pass through the center of mass and parallel to the given axis. So that means like this. Okay, chila hi center of mass na. About the center of mass of pita solid sphere achu 2 by 5 mr square. Okay. Atira d chu pide ham. So here this is d na. So here d is equals to what? The radius itself. Okay. Ale formula to apply lechun I is equals to ICOM plus md squared. So ICOM chu pi ham 2 mr square by 5 is a plus m into d chu pi ham r na 2 mr square. So how much is this? 7 mr square divided by 5. Okay, so this is your answer. Okay, so theorem in theorem valachun na patian theorem valachun. So you can find the moment of inertia anywhere. Okay, anywhere on the solid or rigid body. Na rigid body hui line dong sa na ball thai. Suppose at a distance of r by 4 ati zo na ball thai na chala hi. Aji cho formula ni hata chala ball an cho axis khat center of mass ala ding in tin. So ICOM cho na ba ha diu na zo ka kapi ho cho. Okay. Right, next you have the next theorem. Abana pahi. So theorem of perpendicular axis ke tijo ji. Theorem of perpendicular axis theorem. Chicho piti na ha. Badang. Hita hi axis thomom jo. So they are all perpendicular to one another. Okay. X-axis, Y-axis to Z-axis. To achu axis niya hai na. Along the two axes, if I know the moment of inertia, I can find the moment of inertia about the third axis. Example jo chilang ahi I ka heda na. Chilang ahi I ka heda la chun. Hi chilang Z axis a I pa jo piham. So Y axis a pa to X axis a pa to Y a pa jo ka plus a la chun na. So that will give me the moment of inertia about the Z axis. Okay, so this is the formula. Right? Batang hi chiong hi Ix equals to Iy plus Iz jong thai na ji. Or Y equals to Ix plus Iz jong thai chu. So any two perpendicular axis a moment of inertia ka head ala chun amani chu ka plus ala chun third axis a moment of inertia pa chu na chipa jong po do de chu. Okay. Let's solve one or two more questions. Find the moment of inertia of a uniform ring of mass m, radius r, about the diameter. Ring chun here chala ring chu chi hi. So this is the ring, right? Radius chu piham r. Okay. To question chun bido about an axis along the diameter jo. Diameter jo hoilang ha. So this is the diameter. Okay, along the diameter. See, if it is a ring, okay. Ring hiti hangumal chun about the center of mass achu here chuna chepen hi. Okay, about this axis is what? mr squared. Okay, hichi axis pa he piha. So into the plane, okay, in the jelly figure pa na. So in this figure, hichi pa na, hichi axis pa hi. So now it is into the plane, okay, like this. Right? Atila chun hichi axis ai ka heda. See, I have to find moment of inertia about this axis. I'll say I. Okay, I tiu ta chala na. So here, if I take another axis, okay, perpendicular to this, hichi pa jong hi I hi chu. Aji chu ring chu symmetry chu, ring is symmetry. So hichi I pa to hin, tu hin hichi I pa hi velu chun, ki hi na ma cham no pi a ring chu. Okay, hichi pa hi I hi le chun, hichi pa jong hi I hi ngai. Okay, so same moment of inertia. Atila chun, to chu axis khat chila kana ya, axis khat chila kana ya, aban axis khat chu into the plane Z axis cho chala hi. So that means if I add two of them, I will get the third. Two chu piha chito hin chi perpendicular chu chiteni ka add ala chun, so it will come out with it will be same as the value to that of this one. Na chi pa hi. Okay. Chu piham, so I plus I should be equals to mr squared. Okay. Hichi axis pa hi na. it's like axis pa here. So here about this is mr square. So this will be equals to the sum of moment of inertia about this axis and this axis. Okay, I plus I. Is that has like 2I is equals to mr square, or I is equals to mr square divided by 2. Okay, very important result. Ring moment of inertia of a ring about the diameter. Okay, along the diameter chu piham mr square by 2. This ka to ki bang chu. Okay. Next you have moment of inertia of a uniform ring. To chu ring ham. Ring na. So here this is a disk. Okay, not a ring. So here this is a disk. Disk of mass m, radius r, about axis passing through the center and along the plane. So along the plane tichu simple ta aside along the diagonal tinacho. Diagonal the diameter na. Azo ring ta bang chu. So here I have, I'll try to draw a disk. Suppose let's say this is a disk. Atila chun to hi question chun pido ha along the plane and passing through the center. Na chichu along the diameter tinacho chi. So here they ask you to find I. Step chu ki bang chu chun. So if I take another axis here perpendicular to the first axis, chijong hi I hi chu. This is also similar, they are uniform symmetrium. So here along this side also it is I, along this axis is also I. Okay. So this is I, so this is I, but this part will be head of a. So if a disk is like this, along this axis we know. Depends on mr square divided by 2 head. So IOCOM. So along this axis we know it, okay. Into the plane or out of the plane. So here along this axis we know, so which is mr square. Atila chun perpendicular axis theorem acho ni chu kasama la chun third part chu ki bangne na. So I will have here I plus I is equals to, so this is mr square by 2. Mr square divided by 2. Okay. So 2 into I equals to mr square divided by 2, or I chu piham mr square divided by 4. Okay. Moment of inertia of a disk along the diameter. So you have to remember. Okay. Okay. I think we have 2 more problems. Na. To hi medical exam question na chong hi. Matang 4 figure ki pi chu chala hi. Hi figure to dong zu hi option ki pi na chala hi na select diu chu. So first thing, ama sa pena chu veta ring kipi na. So ring is given, A is ring, B chu piham, B chu disk, C chu hollow cylinder, abana D pa ho solid cylinder. Okay. Atile ama sa pen pa he na A pa hi axis hi value chun chi axis chu. Okay, ring hi ta ma chi axis na. Khutil chun ICOM ki dong tine chu chala hi. Okay, so what is this value? mr square. Ring a chu na. B na pa ho piham, so B na pa he value chun axis hi along the plane, along the diagonal diameter. Okay. Tu ay bol sat pen chu na. Isa nang poram chala hi mr square divided by 4. Okay. Hicho hin na by hat so pen hi. Abana thum na chu C chu piha. Hollow cylinder na along the axis chu pita. Ring to ki bang thiu chu na chala chu. So this is mr squared. Okay. Abana solid cylinder chu pita. So this to ki bangi thiu chu na pen here. So mr square divided by 2. Okay. So this is ID, IC, IA, and then IB. Okay, what is the relation? Question chu pi do first pa ho value chun A to hin C ki bangam. A chu chi hi za, C chu chi ki bang na. Abana so 2 times of IB equals to ID. Diam 2 times of IB. It's multiply by 2 boleng mr square by 2 cancel mr square by 2 po de na. Abana so D chu piham mr square by 2. So first option is correct. Na D sing da so. Okay, you can check the rest of the option also. Okay. Okay, last question. JEE question khat na chala hi. The moment of inertia of a circular ring, mass m, diameter r. okay diameter r atile radius chu jat diham radius chu half of diagonal, so that means r by 2 half of diameter na. So along the tangential axis lying in the plane na dicho. So ring khat draw leng. So I have a ring like this. So along the tangent chu na. So this is along the tangent and it should be along the plane na dicho chala he. So chipa hi AB a hi lechun. So it will rotate about this axis. Okay. Radius chu jat ke PM radius chu r by 2. Okay. Atile hin chila hi theorem ma sapa chu na parallel axis theorem pa chu man chu chala hi. So here in order to use that I have to take an axis passing through the center of mass and parallel to the given axis. Okay. Hichipa hi ICOM kan ti cho. Ai hi wanga cho ringa mr square pa kho chi hi lo cho chi. As you say about center of mass cho axis khat bo se am hi lo cho. You also have another axis, this one, into the plane pa he na chi. Hichipa hi za ta chipa hi mr square mo zo na khat ve cho. Ai wanga to axis pa hi along the surface pa cho, along the diameter as a itself pa cho. So this is how much mr square by 2 chola na as also. So m into r chu be r by 2 square divided by 2. Okay, mr square by 2. Mr square hilaw na mr square by 2 along the diagonal passing through the center of mass pa cho. So how much is this? Mr square 2 to the 4 to the 8 by 8. Okay, what is d? So d is the separation. So d is equals to the radius r by 2, right? Okay, so you apply the formula. I equals to ICOM plus md squared. ICOM chu biham mr square divided by 8. Okay, plus m into d chu biham r by 2 whole square. That's it. So mr square divided by 8 plus mr square divided by 4. So if you solve this, you'll have, so this is 8, so this is 2. So 3 mr square divided by 8. Okay, so this is your answer, option A. Hitan hi na, chi video hin bolutin. To the moment of inertia hi non-uniform hua ko na. Hi so jong ko ma chukit le cavity problems jong ke na aban le radius of gyration ke ti kham ke beta jo. So these things we will try to do in the next video, right? Okay, so I hope you understand. Moment of inertia ki hold na system of particles to rigid body sa chu chi video hi bol ta cha. Right, we'll stop here. I'll see you in the next video. Okay.